I'm a neuroscientist, and I'm the director of the Picard Institute for Learning and Memory and a member of the Department of Brain and Cognitive Sciences at MIT. I'm leading the Aging Brain Initiative of MIT. And today, I'm going to tell you an example of our unconventional approach that we are calling the power of gamma. So in current effort to treat Alzheimer's disease, the options are very limited. Only 4 drugs were approved, some more than 2 decades ago, but very little has followed since then. None of these drugs can reverse the disease, but only provide very brief relief to symptoms. Here is an astonishing fact. 99.6% of all the late-stage clinical trials failed. We know that drug development is very risky, but this number is unusually high. Okay? The major approaches in the field, and in particular in drug industry, to target Alzheimer's is to target genes and molecules. So over the last 30 years, we have come a long way in understanding the genes and molecules that contribute to the disease. But this type of approaches have yet to work. For instance, the amyloid hypothesis has been dominant in the field for decades. Currently, all the drugs designed to target the amyloid, either to reduce its total level or to interfere with its production, have all failed. So out of this extremely fertile environment, I get to work with engineers, computer scientists, systems neuroscientists, and physicians. Together, we decided to take the opportunity to take a closer look at how network connectivity in the brain changes and how it relates to the development of Alzheimer's disease pathologies and symptoms. Now I'm going to tell you a fascinating property of our brain. That large number of connected neurons can fire together synchronously to produce rhythmic oscillations, or we can call it brain waves. There are many different oscillations identified in the brain. And these different oscillations are evolutionarily conserved from mouse to humans. Okay? So at the lower side of the frequency spectrum, we have so-called alpha wave, which is associated with sleep and memory consolidation. And we have theta waves, which are known to be associated with memory formation. And we also have higher frequency oscillations, such as gamma oscillations and sharp-wave ripples. So why do we need all of these oscillatory synchronizations? Neurons engage in specific functions. Cognitive processes depend on coordinated interactions of these distributed large-scale neural networks. So these highly organized connections can generate rhythmic electrical activity, including gamma oscillations. So you must be wondering, I've mentioned several times now gamma oscillations. So what are gamma oscillations for? So it is known that gamma oscillations in the brain are involved in higher order brain functions, functions like sensory perception, attention, and working memory. And most importantly, gamma oscillations are known to be disrupted. We found compromised gamma oscillations in this young Alzheimer's mouse, asymptomatic or pre-symptomatic Alzheimer's mouse. And in addition to reduced gamma power, we also found other abnormalities in terms of the spiking pattern of the neurons in the brain. So with this compromised gamma power, we wanted to know whether it is possible to bring the gamma oscillation back to the brain. And if we do that, what will happen to the brain? So how do we do that? Turned out, in the early 90s, researchers found that by shining a light with a specific frequency pattern to cats can cause the neurons of the visual cortex of the cat. So the visual cortex is the part of the brain responsible for processing vision, to produce rhythmic oscillations at that particular frequency. So we were skeptical. So we were together with Emery Brown and Ed Boyden and Earl Miller. We produced a LED light box where we can house a mouse in it and also flicker the light at the gamma frequencies, and especially around 40 hertz, using an Arduino motherboard, okay? So what I'm about to tell you is some results. It still gives me pause as I'm speaking today. I still feel like I'm living in a dream, okay? So what we found is that after we kept the mouse in this light box with this 40 hertz flickering light for 1 hour, and then we evaluate the amyloid in the brain, what we found is a profound reduction of amyloid. So this is just after 1 hour of this flickering light. So I'm also showing a lot of control conditions just to make sure that this effect is very specific to this gamma flicker training. So this is mouse kept in a constant dark, constant light, and this is 1 hour of 40 hertz gamma treatment, about 50% reduction of brain's amyloid. And if we treated the mice with 20 hertz or 80 hertz, there is no reduction. So this is extremely specific to 40 hertz. So amyloid is known to be mainly produced by neurons in the brain, okay? So I use this cartoon to just illustrate the point. So this brown stuff is amyloid, say, and we found that after gamma 1 hour, production of amyloid from these neurons is reduced. And this is very exciting. But we actually see something else spectacular, which is the effect on microglia. So the microglia are the brain's immune cells, and they are also known to be the scavenger or the janitors of the brain. They normally take up infectious agents such as bacteria or viruses or toxic waste such as the amyloid from the brain to keep the brain healthy, okay? So in this cartoon here, the microglia are depicted as these green cells. And we found that after 1 hour of 40 hertz stimulation, these microglia, which are very impaired in terms of its function in the Alzheimer's brain, undergo the most drastic transformation that has never been seen before. I'm showing you the original data. Look at the microglia in the brain. You can see this microglia after 40 hertz gamma training for 1 hour. They definitely look very different from the microglia before the training. They are more abundant, they are much larger, they look more complex. But most importantly, they become much more active after they kind of puff up. They become much more active in taking up this amyloid into their belly and chewing this amyloid up. So we decided to treat the mice 1 hour per day for 7 days. And here, I'm also showing you the data from treating older Alzheimer's disease model when these mice already show memory loss and show huge amount of amyloid load and plaque load in the brain. And you can see this is before treatment, all this cotton ball-like amyloid plaques, and after 7 days of treatment. We found drastic reduction in both the number and size of these amyloid plaques after chronic repeated theta gamma treatment. So just to summarize what I told you so far, we found that shining the light to the mice at the gamma frequency, especially 40 hertz, can drastically reduce amyloid load and the sticky plaques in the brain. And this is mediated by at least 2 different mechanisms. One is the reduced production of amyloid by neurons, and the other is a hugely enhanced clearing ability of microglia to get rid of amyloid from the brain. But most importantly, those mice with impaired learning and memory can learn again. And their memory is restored on a wide range of behavior tasks. So here I'm just listing all the behavior phenotypes we have observed so far. They show reduced anxiety, and actually increased anxiety level is a feature of Alzheimer's disease patients, okay? And they showed improved spatial learning, spatial memory, improved object recognition memory, improved object location memory. And also now we have treated these mice extensively for months and months, and we haven't seen any adverse effect developed by the animals. And in Alzheimer's patients, we know that neurodegeneration and pathology is distributed in many different brain areas. So what we are doing now is to further figure out whether stimulation of other sensory modalities can achieve similar effect. If some other sensory stimulation were better even than visual stimulation, and can a combination of the stimulation work even better, okay? And what's new in terms of our approach is that we are not targeting a specific genes or molecule. By restoring gamma oscillations, we are seeing a broad and systemic effect by affecting many different cell types and many different processes. And one of the important mechanisms seems to involve enabling the brain's intrinsic repair mechanism. So now it's time for us to think about human subjects. Many people ask me about application to humans because the approach is so non-invasive. And indeed, if human can react to this treatment similarly to what we have seen in animal models, then this could be life-changing for millions of families. So this is a commercially available light flicker. This is very strong, so be prepared for that. So there are a number of devices that one can contemplate to use. With your support, we can make a better world. Thank you very much. Do we have time? Maybe I can take 1 or 2 questions. I know it's late.
I'm wondering, have you done any anecdotal early human testing that you can tell us about?
There are a lot of anecdotal human, data that people just send me emails. I got all these emails all the time, and some people just say, "Thank you so much for coming up with this this idea, and we created a homemade flickering device, and some miracle happened to my mother. She couldn't watch TV, she couldn't follow a TV program, and now she can follow. She didn't have to ask any question." Or someone else told me that, their dad cannot eat breakfast anymore, but then after several weeks of stimulation, they, eat breakfast again. But this is really individual, isolated, anecdotal kind of observation. What we really need is a well-controlled clinical trials and human studies. Thank you.
Some wavelengths seem to be very good for relieving pain. So blue light particularly, and you probably know that Philips is selling a blue LED patch called the Blue Touch for lower back pain. Other folks are starting to use blue light for painful conditions. People say red light is good for relieving inflammation. So, inflammatory conditions. I think near-infrared is good for regenerating things, possibly because things that need regenerating are usually deeper, tendons and bones and these cartilage. Things that need regenerating are usually deeper inside, and it's quite clear that near-infrared penetrates better. I think everybody agrees on that. Obviously, one of the big growth areas is the brain, and this is really intriguing because folks find benefits in the brain by putting all sorts of light on the head. High power near-infrared lasers and high power LEDs, but relatively low power devices that can go up the nose, they can go in the ears, they can go different parts of the head, and everybody thinks, well, the photons have got to get in the brain, so there's got to be a certain power density. Photons can be absorbed in the blood. You have blood circulating in your scalp. You have bone marrow in the bone of your skull, and it's known that light is very good at activating stem cells in bone marrow. That's one of the big deals. Clearly that photobiomodulation has huge effects on the brain. Still, the jury's out. What is the best way to get the light in your head?
Well, you're actually involved in a number of studies to answer that question, especially with respect to treating neurodegenerative diseases like Alzheimer's.
Yeah, absolutely.
So maybe you could summarize what you've learned to date.
Yeah. So, there's only been a few studies so far about photobiomodulation for Alzheimer's. And since Alzheimer's is going to be the huge epidemic and it's going to decimate healthcare costs and all this, the fact that most drug trials for Alzheimer's have failed dismally, right? I mean, at the cost of billions of dollars, and like a few folks with small trials for Alzheimer's get results so good that nobody can believe them. These are people, old folks who can never set a coherent sentence in weeks and months, suddenly kind of start talking with their relatives. And people who have to be fed suddenly start using a knife and fork. I mean, a lot of people just can't believe it. And, we do have some statistics that only relatively small series of patients, but we do have statistical significance. And in my opinion, the effects are so surprisingly good that this has to spread. I mean, it really has to spread. People have to do big trials, and I would expect in 5 or 10 years that photobiomodulation for Alzheimer's has to be pretty much out there.
I traveled out just outside of Toronto to a community called Orangeville and met a very dynamic couple. A couple that is part of our ongoing investigation into photobiomodulation and how it affects Alzheimer's disease. have a look at this.
We signed up for this study. I thought, it's kind of strange. They're going to use light.
Yeah. Well, I still can't understand how light does anything, but without the sun we wouldn't be here, so
Yeah.
that's my way of looking at light.
When I married Doug, I knew that his condition was going to continue to deteriorate. I knew the kind of personality he had, and I had worked quite a bit over the years because I worked in community health care.
Well, when we were first together, the disease had kept moving forward, and it started to get that nothing was really bright. After the treatment, things started to brighten up. My whole spirit seemed brighter. I felt my personality coming back, and I could handle pretty well everything then.
Do you know anyone who experiences Alzheimer's or dementia, whether it's early stage or later stage progression? Have them join this movement. Together, we can make a difference.
I get a lot of emails from folks asking me what device they can buy to use at home, because a lot of these folks do not have a lot of money. So I tell them to look for near-infrared security floodlights. So these are 850 nanometers, and they're sold so that various companies can have an invisible security light with an infrared camera, so intruders can't see they're being filmed. And these are powerful, so you can get 70 or 100 watts of optical power.
Wow.
$1,000, a few $100 sometimes. And if this was a laser, it would cost you $100,000.